Today we are going to learn about advanced customization of Matplotlib scatterplots. We'll explore techniques to enhance data storytelling with Matplotlib by applying advanced styling and features to scatterplots. Welcome to our video on advanced customization of Matplotlib scatterplots. Data visualization is a crucial tool in data analysis, and scatterplots are one of the simplest yet most effective ways to visualize relationships between variables. However, the default scatterplot settings in Matplotlib might not always convey your message as effectively as possible. Customization allows you to highlight key data points, apply color gradients, and add clarity to your visualizations. In this video, we'll delve into advanced techniques to make your scatter plots not just visually appealing, but also highly informative. From customizing marker styles to applying color maps and annotations, we'll cover all you need to know to enhance your data storytelling.
Before we dive into advanced customizations, it's important to understand the basic elements of a scatter plot. A scatter plot primarily consists of data points plotted on a two-dimensional graph, where each point represents the values of two variables. The position of points on the plot helps visualize any patterns or correlations. In Matplotlib, scatter plots are created using the plt.scatter function. Key parameters include x and y for data coordinates, s for marker size, c for marker color, and marker for marker style. Understanding these basic parameters is crucial as they form the foundation for more complex customizations. Additionally, setting up your Python environment with Matplotlib is necessary, which involves importing libraries and preparing your data for visualization. Markers and scatter plots are the visual representations of data points, and customizing them can significantly enhance the plot's readability and aesthetics. Matplotlib offers a variety of marker styles such as circles, squares, diamonds, and more, which can be specified using the marker parameter. Choosing the right marker style can help differentiate between categories or highlight specific data points. Marker size, controlled by this parameter, is another critical aspect. Size can be static or dynamic based on another variable, adding a third dimension to your plot. For instance, representing population size with varying marker sizes can provide additional insights. Experimenting with different shapes and sizes is key to finding the most effective representation for your dataset.
Color plays a vital role in data visualization, and Matplotlib's color maps are a powerful tool for enhancing scatterplots. A color map specifies a range of colors used to represent data values, providing an intuitive way to visualize variations in data. Choosing the right color map is crucial, as it affects the readability and interpretability of your plot. For continuous data, gradient color maps like Viridis or Plasma are effective, while categorical data benefits from discrete color maps. The CMAP parameter in plt.scatter allows you to specify the color map, and the C parameter can be used to determine which data variable dictates the color. Color maps not only make your plots visually appealing but also aid in better data interpretation.
Annotations in scatter plots serve as a means to provide additional context or highlight specific data points, making your visualizations more informative. Matplotlib's annotate function allows you to add text annotations at specified data coordinates. This is particularly useful for emphasizing outliers, key observations, or important trends within your data. Annotations can include arrows or connectors to guide the viewer's attention, and you can customize their appearance with font styles, colors, and sizes. By carefully annotating your scatter plots, you can enhance interactivity and ensure that viewers grasp the significance of the highlighted points. Axes and grids form the structural framework of a scatter plot, and customizing them can greatly improve the plot's clarity and organization. Axis labels should be descriptive and concise, providing viewers with a clear understanding of the data being represented. Matplotlib's label and label functions allow you to modify axis labels, while sticks and geeks can be used for custom tick marks. Customizing grid lines with a grid function can enhance readability, especially in dense plots. Adding secondary axes using twinks or twiny can be beneficial when comparing different scales. Through thoughtful axis and grid customizations, you can create a structured and visually appealing plot. Titles and legends are essential components of scatter plots, providing context and aiding in plot comprehension. A well-crafted title gives viewers an immediate understanding of the plot's purpose, while a legend explains the meaning of different marker styles, colors, or sizes. Matplotlib's title function allows you to set a plot title, while legend is used to create legends. The positioning and appearance of legends can be customized to ensure they don't clutter the plot. By incorporating informative titles and legends, you can guide viewers through the data more effectively, enhancing the overall clarity of your visualizations.
Subplots allow you to display multiple scatter plots within a single figure, facilitating comparative analysis of different datasets or variables. Matplotlib's subplot and subplots functions provide a convenient way to create grids of plots with shared axes or independent layouts. By juxtaposing related scatter plots, you can highlight differences, trends, or correlations that might not be evident in isolation. Customizing subplot layouts, such as adjusting spacing and alignment, ensures that each plot is easily interpretable. Subplots are particularly valuable when dealing with complex datasets, enabling viewers to draw insights from side-by-side comparisons. As you incorporate advanced customizations into your scatter plots, it's crucial to maintain readability, especially in complex plots with numerous data points or variables. Avoid clutter by limiting the number of elements on the plot and ensuring that text and markers are not overlapping. Balancing detail and simplicity is key. Provide enough information to convey your message without overwhelming the viewer. Effective use of white space can enhance the plot's aesthetics and improve data visibility. Selecting appropriate plot dimensions and aspect ratios is also essential for readability. By prioritizing clarity and simplicity, you can create compelling scatter plots that effectively communicate your data insights. In conclusion, customizing scatter plots in Matplotlib is a powerful way to enhance data storytelling. Throughout this video, we've explored various techniques, including marker and color map customizations, annotations, axis adjustments, and more. Each of these elements contributes to creating visualizations that are not just aesthetically pleasing but also effective in conveying insights. Remember, clarity and readability should always be at the forefront of your visualization efforts. We encourage you to experiment with these techniques and explore additional resources to deepen your understanding. Thank you for joining us on this journey to mastering scatter plot customization, and we hope it inspires you to create impactful data visualizations.